Ay, 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 ay. Okay, so today we're going to talk about the application of solving vector resultants. And we have, hopefully, masumata ang tatlo problems within the time constraints that we have. Okay, just to remind you guys, we are still going to use the 4 formulas. So you may write this down on your papers as you study along with us. F of x is f cosine theta for the x component. F of y is f sine theta for the y component. That is if you're given the magnitude and direction of your vectors. Meanwhile, if you're given the x and y components, you may solve for the magnitude by f of x squared plus f of y squared, square root sina. And the direction or angle is arc tangent f of y over f of x. Okay. Also, remember that your theta that you're going to use for the components should start from the origin, so 0 degrees gid. Okay, let's go to the first problem. So we have here a hiker begins a trip by walking 25 kilometers southeast from her car. So we are going to draw a little gamay nga XY plane and 25 kilometers southeast. So tunga-tunga din sa south kag east. Lipoton ta lang. And let's call this vector A kay siyang una. 25 kilometers. Anong angle gamiton ta? So since ours is tunga-tunga, no, so we can say that this is 45 degrees. So you may use negative 45. You may use 360 minus 45. That should give you 315 degrees. So, ang aton nga gamiton sa akon, gamiton ko is 315 degrees. You may use negative 45 as well. You may also analyze it this way. So, 90, 180, 270 plus 45. Ang makuha nyo is also 315. Okay? And the next vector. So, on the second day, she walks 40 kilometers in a direction 60 degrees north of east. So, I'm going to draw another XY plane. Nagamay. North of east. So, sa babaw ni east, 60 degrees. So, medyo hapos lang ang pagbutang sa angle. And I think this is long enough. Tawagon ko ni siya nga vector B. 40 kilometers and 60 degrees. No problem. So these are the two vectors that we're going to use. Now the resultant should look like this. From the head, no, sa ato nga second nga vector to the tail of the first vector. Amo ni ang displacement sang ato nga hiker. This is the resultant. Because of this, guys, this graphical representation of our vector problem is called your head-to-tail. Head-to-tail method. No? Okay. But, ang naangda nato niya sa class is using the parallelogram method na siya actually. Kay dumapuslan gid siya when it comes to your component method. Nananamian ko yung magamit. So, let's show same lang makuha natin ng values, no? So 45 degrees sa tunga-tunga siya abisang south kag east. This is our first vector A. And then the second vector is 60 degrees north of east. So sa babaw ni east, gapaamo ni siguro. Laba-laba pagid. Yep. And this is our vector B. So, how do we do the parallelogram method? So, i-mirror naton ang aton nga vector A dire. So, opposite sa iya. And then, let's mirror as well our vector B. Okay. And then, the line that divides or bisects this parallelogram is this. So, from the origin, pakadto sa heads sa aton nga duha ka vectors. Nga mirror. This is our resultant. It's not obvious. I'll try my best na ang aton sini nga resultant is somewhat same sa aton nga head-to-tail method. Ay! Charot, same ni sa ako lang na pag-drawing na kire. Pero as you can see, ang 45 degrees ko no alang-ala siya, oh. And then ang akon na 60 degrees lang alang man. So medyo kiwi lang akon resultant, but otherwise it's the same thing. Okay? So you have the option to either, I think hindi ko save. Yeah, you have the option to either use the parallelogram method. So I'll just write this down. Parallelogram method or the head-to-tail method to represent your vectors. Since we always use parallelogram method in class, let's use head-to-tail for this video. Okay. So, now, for part A of the problem, determine the components of the hiker's displacement for each day. So, A of x, A of y, B of x, B of y, equals. A of x, 25 cosine 315, and 25 sine 315 ang AY. For B, that's 40 cosine 60, and 40 sine 60. So you have your calculators and let's solve together. 25 cosine 315. Okay, 17.68. Follow the unit kilometers. 25 sine 315 is negative 17.68. Also, notice guys, if we're talking about quadrants, ay di na lang, amon lang nga analysis ko. Ang ato nga vector A, ang iya nga it's pointing towards the right. So, positive x. Kagapadalom siya, so negative y. So, positive aton nga x, negative aton nga y. Tsakto. Si B naman aton, kapatudlo man siya pababaw, so positive aton y. Kagapakadlo man siya sa right. So, positive man ang aton nga x dapat. So, try ta 40 cosine 60. 20. O, positive. Yehey, lipay ka. 40 sine 60 is 34.64 kilometers. Also positive. So, tsakto kita so far. Okay? So, for part A, that's it. These are all the components of the hiker's displacement for each day. For the first day, so for the second day. Okay. Now, for part B, determine the components of the hiker's resultant displacement. So, the resultant displacement, siya na ang total nga, kumbaga total na component para sa x and total component para kay y. So, that is, r ang gingamit mo, tiwa r mo ko di. So, tingnan na lang ko, rx is equal to 17.68 plus 20. So, this is 37.68 kilometers. This is the resultant component for x. And resultant component for y is negative 17.68 plus 34.64. 4.64 minus 7.68. 16.96 kilometers. So these are the resultant components. Okay. Now, may bago kita din na term, kasi bago sa inyo. So, find an expression for your resultant in terms of unit vectors. So, let's talk about unit vectors for a second. Okay. Okay. So, you should already know that our vectors can be represented with I, J, and K. So, that is for the X, Y, and Z components. In our case, it's only I and J. Okay. So, our vectors make use of arrowhead, pares ng R ni arrowhead. Nan. Pero, ang aton nga unit vectors, gina-represent na siya sang hat, like this. Okay. And, it is, ang iyang formula is I plus J. Kung mera pa da plus K, goods, no problem. So, I plus J lang kita. All over. Ang ini na symbol, absolute value ni siya, no? Pero sa vectors, magnitude na siya. So, magnitude sa vector R na to. Okay. So, what are unit vectors? So, they are vectors that point toward the direction of your original vector. Pero, ang iyang resultant ni mo 1. Check nyo bala. So, for us to be able to solve our unit vector, may I na kita. So, ang I natin gamitin karon 37.68. No, kay siya ni ang resultant x. May j naman kita, 16.96, kaysa ni ang resultant y. Ang kulang is the magnitude for r. So, let's solve it. Okay. Square root of 37.68 squared, 16.96 squared. Okay. 37 squared, 16.96 squared. It's 41.32 kilometers. Para lang trip-trip sulbon ta na ang iyang direksyon na. So, arctangent, 16.96 over 37.68. So, arctan, 68. So, we have 24.23 degrees. Okay. So, supposedly guys, our unit vector should point towards 24.23 degrees. Now, our unit vector is solved like this. 37.68i plus 16.96j all over ang magnitude solve naton 41.32. Dason, i-consider nyo ni si I kag j nga do the variable. So, isa-isa ho nyo ni siya divide. So, 37.68 divided by 41.32. Ang makuha nyo, 0.91 I plus 16.96 divided by 41.32. So, ang makuha nyo na dapat is 0.41J. Siya ni ang unit vector. To make sure, kay sa lingkod, diba, ang iyasin nga magnitude is 1. Kay unit mo, unit. Well, it talks about 1 unit vector. So, you can go ahead and square root 0.911 squared plus 0.41 squared. Since we are rounding up or rounding off, ang makuha ato nga value is not exactly 1, but I got 0.999. Lapit Japon sa 1. So, this is therefore the answer for part B. As for the unit vector, otherwise, for the components of the displacement, we have this and this. For all the displacements, for all the components, we have this for part A. Go ahead, take a picture, and yeah, screenshot. Pause. Now for the second problem. So, let's get rid of this. Okay, so may drawing na nga daan. A jet airliner moving initially at 300 miles per hour to the east. So, ari siya, ginsampaw ko lang siya gamay sa aton nga x-axis para kitaon siya. And suddenly, it enters a region where the wind is blowing at 100 miles per hour towards the direction 30 degrees north of east. So, sa babaw ni east, drawing on to si 30 degrees. Question, what are the new speed and direction of the aircraft relative to the ground? So, tapos lang eh. Okay? So, as you can see, our drawing is already in the, kumbaga, the free body diagram na nga drawing mo. So, familiar na ka mo sila eh. Yeah, let's actually use P and W as our vector names, okay? So, yeah, for the components of vector P, you don't need to solve for y. X lang yun. Kaya abot mo ng a 0. Kaya wala siya sang y component. Pero si x naton is positive 300 miles per hour. If you are not, if hindi ka mo kumbinsido, test din eh. Okay. Ang ato nga p of x is 300 cosine. Ano ni nga angle? Tagapahigda siya sa origin. Therefore, 0 ni siya. Ang ato nga y is 300 sine 0. You can go ahead and you'll see that 300 cosine 0 is still 300. While 300 sine 0 is 0. Okay? If you're going to show me that you didn't solve for this part because you already understood, then defy ko. Okay. As for the components of the wind, for Wx, we have 100 cosine 30. And Wy is 100 sine 30. Okay? 100 cosine 30 is 86.6 miles per hour. And 100 sine 30 is 50 miles per hour. So now the question is, what are the new speed and direction? So let's make this a bit smaller. Oops. Do map. Pasang lambot nga lugar ba? Yeah. Brush. Okay. Resultant. X component. It's 300 plus 86.6. Resultant sang Y is 0. And wala naman sa iban pa, 50 miles per hour. So it's 386.6 miles per hour. Now the resultant is the square root of 386.6 squared plus 50 squared. So, plus 50 squared. So, it's 389.82 miles per hour. Dasig siya. Ang iya nga theta is arctan. Y is 50 over 386.6. So, our tangent, 50, 386.6, should give you 7.37 degrees. So, it's a good thing. Analyzing this, oh, by the way, butangan yung square. Butangan yung square. Ang new speed, new direction. So, our plane is moving towards the east. And we have wind. We have the wind that is moving 30 degrees north of east. So it is pushing your plane indeed towards the east. So medyo madasig-dasig siya. However, it is in a weird angle. So it's not directly moving east. It's now 7.37 degrees. Moving towards the northeast or north of east. So your pilot has to adjust. Our ECE students will eventually be familiar with your ILS, instrument landing systems, and GWPS, and all of those instruments with regards to airplanes. So it's a fun topic, fun subject when you get older. Yeah. So that's our problem number 2.